Hi everyone. My talk is called ReasonML for JavaScript developers, and my main goal today is just to familiarize yourself with the syntax of ReasonML. So this is like the most ReasonML 101 that you could imagine, so we're starting out at the very, very beginning. So my name is Marius. I'm currently a freelance developer, and yeah, I've been dabbling with ReasonML for a couple of months, and I think it's a really, really, really exciting project. I have really high hopes for it, so I hope I can get you excited today. So the idea behind this talk is that I show you a certain piece of JavaScript code, and then we're going to look at what it looks like in Reason. So let's start with the most basic thing we can imagine, some basic variables. So let's say we have a variable called Meetup name that is set to some completely random string. In JavaScript, what would that look like in Reason? So as you've seen, I've color-coded all my slides. So in the upper right-hand corner, you can see what language we're currently in, because some things look really, really similar between Reason and JavaScript. So this is what it looks like in Reason. Instead of the const keyword, we're using let. So if we use const in JavaScript, this means we cannot assign a new value to Meetup name later. So we can only assign a value once, and we have to do it right away. And this is exactly the same behavior as ReasonML's let keyword. ReasonML doesn't have const, so we can't say const Meetup name in Reason. So let's say we have a JavaScript let value. So if we declare a variable called counter in JavaScript using the let keyword, we can change it later. For example, we can increment it. And if I rewrite that slightly, so if I say counter equals counter plus 1, we're still in JavaScript. And this is what the same syntax would look like in Reason. And it already looks a little bit different and maybe a little bit scary. It's really not that bad. So as Axel said before, ReasonML is both object-oriented and functional at the same time, which means we have immutable language features and mutable language features. And if we want mutability, so if we want the ability to change the contents of a variable, we can use ref, which you can just imagine like a box. So a ref is a box which contains a certain value at a specific time. And we can change that value over time. So what I do in this example is I initialize a box with the value 0, and in the next line I put in the value 1. It's not as simple as the JavaScript syntax, where we could just say, counter equals counter plus 1, but it does the same thing. So here we have to say colon equals instead of equals, and we have to use this, what's it called, the circumflex? Yeah, thanks. The hat symbol. So this is what mutability would look like in Reason. All right, not too bad, is it? I mean, you have to get used to it. I admit that. My first thought was, ugh, that looks ugly, but it's really not that bad. All right, that was variables. Now let's do some very basic string concatenation. So here again is a JavaScript example. I have, again, the totally random string Munich ReasonML, and I'm using string interpolation here, using template literals. We can rewrite that in JavaScript. Again, we can say, we use string concatenation using the plus operator in JavaScript. And in ReasonML, because it's twice as good, we use 2 pluses for string concatenation. And again, we don't use const, we use let. Okay? Not too bad. I mean, you can get used to that, right? You just write 2 pluses, yeah, that's it. This is already the third plus operator you've seen tonight. We've seen integer plus, we've seen plus dot for floating point addition, and we've now seen string plus, which is plus plus. All right, let's talk about arrays. This is a JavaScript array with 7 weekdays. I was confused about that at first, but if you look it up, the value 0 stands for Sunday in JavaScript, because English-speaking countries start counting at 0, they mean Sunday as the first day of the week. So this is why I put it this way here. And the syntax, again, just regular JavaScript. We changed the 5th item, so the item at index 4, to reason day. What would that look like in Reason? Pretty similar, except that by the way, my syntax highlighter doesn't understand the difference between variables and functions in Reason yet. So it paints everything in green. Green stands for function. Ignore the syntax highlighting. So yeah, this is an array in Reason. As you can see, we're using an opening square bracket and a pipe symbol to create an array. We're going to see just in a second why that is. But besides that, that could be JavaScript code. If you just got rid of the pipes, that would be syntactically valid JavaScript. So why do we use the square bracket and the pipe? Well, we need the plain square bracket for something else, for a different data structure, and that's called a list in Reason. So there's no JavaScript code here. This is already the Reason code because JavaScript doesn't have a native syntax for the list data structure. Of course, you can have lists, that is linked lists in JavaScript, but we don't have native language syntax for that. So this is what a list looks like in Reason. We just say opening square bracket and then, some to-dos. And that is almost valid JavaScript. Can somebody spot the one thing on this page that makes this code not valid JavaScript? Yes?
This tick after let to-dos, the second to-dos thing.
Exactly. We have an apostrophe after to-dos. In Reason, it is perfectly fine, so on OCaml as well. It's perfectly fine to have an apostrophe as part of a name. And the convention is usually that this means slightly changed. So if I have a variable called x and I do a slight tweak to it, I can add an apostrophe and mean, it's slightly changed. It's a mathematical notation.
How do you say that with your name?
You don't, probably.
So
Is it prime?
Pronounce it as prime.
Yeah, to-do is prime.
Okay.
I guess. Yeah. You could also leave it out here. That would be valid as well, but then we would have shadowing, and I don't want to get into that right now.
Do you get 2 apostrophes if you change it the second time, or do you?
You can do 5 if you want to.
Okay.
That's amazing.
I'm not recommending this. I'm just saying I'm slightly altering the to-dos list here, so I've given it a different name. I could have left out the prime, the tick, entirely, but then we would have shadowing here, so 2 different bindings with the same name. All right, so what am I doing here? I'm prepending another to-do to my to-dos list. And this is a very efficient operation. So if we have linked lists, it is a very cheap operation to prepend another item in front of the list, because that is what linked lists can be used for very efficiently. You can't do that with arrays, usually. In JavaScript, it's slightly different, but usually in statically typed programming languages, many arrays, or most of the time arrays, have a fixed length. So if you need one more item, you have to reallocate a new array. In Reason, it's slightly different, depends on what you're compiling to. So if you're compiling to JavaScript, arrays don't have a fixed size. If you're compiling to native, they do have a fixed size. But yeah, arrays are really good at random access for reading and writing at a specific index. And lists are really good at prepending items to the beginning. Just notice that we're not modifying anything. So we're not modifying the to-dos list. I'm creating a new list with a new head, so with a new prepended item, but I'm not changing anything. Okay, that's very important. Okay, so this is why we don't use the array syntax here. We're creating a list. Any questions so far? Everybody happy? Except about the ref syntax? Okay. Sorry, I don't want to bash. Okay, functions. Let's look at what functions look like. This is a JavaScript arrow function. It only takes a single parameter called x, so we don't have to write the parentheses around it, although we could. And it has a concise method body, right? The method body is just a single expression. We don't have a block statement here. This is what it looks like in Reason. Just for the dramatic effect again, I'm going to switch back and forward between the two. Although I didn't know if Axel would mention the star dot operator, so the multiply operator for floats. So technically, if this is the JavaScript code, we would have to add a multiply dot here, so asterisk dot, if we wanted to be even closer to the JavaScript version, because that is just for integers.
Okay.
But yeah. We can also write it like this. So just like in JavaScript, we can add parentheses, which is fine, I guess. And here's the first difference. We can also have more complex method bodies, so we can have a block, but the last expression within this block is the return value of this function. So if you call the square function, it returns x times x, and there's no such thing as a return statement. Okay? Because this entire thing, this entire block, is one expression. And that is different from JavaScript. So we can just write x times x, and that's the result of the function. We wouldn't use this syntax, so we would just use the one without braces in this case. But just imagine we have something slightly more complex. We have a greet function. We do some string concatenation. So we have several expressions here. Or we have a let binding and then a function call. So js.log is the JavaScript console log. It just has a different name and reason. Okay, not too bad, is it? Doesn't look too strange, I would say. All right, let's talk about if. So I just called this conditionals because naming it if just felt wrong. So let's say we have a variable, and we want to determine if it's negative or non-negative. So this is what we could do in JavaScript, right? We have a ternary operator, so we have a conditional expression. We check if number is less than 0. If it is, it's negative, and if it's not less than 0, it's not negative. Here's what it looks like in Reason. Again, the only thing that changes is the const and my syntax highlighting. So we can do exactly the same thing in Reason, although we have, in addition to ternary expressions, we also have if expressions. And that is different from JavaScript. So in JavaScript, if is a statement. This means you cannot write an if statement and assign its value to, let sign equals if. That is just not valid JavaScript. Maybe we'll have do expressions someday in JavaScript, who knows? Maybe then we can write something like that, but not right now. So again, this does the same thing as the slide before. So we check if number is less than 0. If it is, we call it negative. Otherwise, we call it non-negative. And again, you can see that within the block, the last expression, which is just the string negative or non-negative here, is the produced value, so the evaluated value of that block expression. If I run the Reason formatter, which is a tool like Prettier, or to be fair, Prettier is like Reason format, the code looks like this. So we have semicolons behind the two strings, but otherwise it's pretty much identical. I think this is pretty cool because if you do nested ternary operators in JavaScript, that can get messy. And I'm pretty sure not everybody knows the precedence of nested ternary operators in JavaScript, right? Are they left associative? Are they right associative? Where do you put the parentheses? So yeah, if you do that in JavaScript, that can look messy. And if you use if-else like this as an expression, you can cleanly nest if and else's. Okay, I don't find myself using if and else as much as I use it in JavaScript, to be honest, because what I use all the time is pattern matching in Reason. So here's the code that does the same thing as the one on the slide before. So again, we determine if number is positive or negative, or if it's negative or non-negative, by using a switch statement, which is like a JavaScript switch on crack. So it can do a lot more. It can do a lot more. Again, it is an expression. In JavaScript, switch is a statement. So this switch produces a value, right? Either evaluates to negative or to non-negative. And we assign that value to the sign let binding. So what do we have here? We switch over the number. And in this first case, so in this first line, we check if number is less than 0. If it is, it's negative. Otherwise, it's non-negative. Does that syntax make sense to you somehow? Yeah?
So do you just get the first statement that matches? Like if
Oh,
it's
yeah.
like 5?
Yeah, all these cases, they're evaluated top-down. And the first one that matches, you take the right-hand side. So after the arrow, yeah. This is very important. So top-down evaluation order is very important because order matters here. If I switch the two, the second one would be dead because I would just always take the first one because it's a catch-all, right? I just take the value. And here in the second case, I actually don't use the x, right? I just gave a name to the number, but I don't use it. So what I can do is I can use an underscore. I hope you can see that. I just use an underscore to mean I want to discard the value. I don't need it. Depends on your preference. I always just leave it out. I use an underscore. Okay. Let's say we now also want to deal with positive numbers. So we also want to say something is, positive, negative, or 0. Because right now we just say negative or non-negative. This is what it could look like. So I can say, we evaluate top down. If something is less than 0, it's negative. It's greater than 0, it's positive. And in all other cases, it must be 0. So we can just use the underscore again and then produce the string 0. We could have also written this another way. We could have also said, first line stays the same, right? If something is less than 0, it's negative. If it's exactly 0, then it's 0. And in all other cases, it must be positive. So we can pattern match against an exact value. And I'm pattern matching against the value 0 here, which I think is pretty cool. Okay, you're going to use pattern matching a lot. So if you write idiomatic reason code and functional style code, you're going to use pattern matching all the time. So if you're reading OCaml code, that is actually called match number with. So this is what the similar syntax looks like in OCaml. Yes?
Would I have to use a dot again after the less sign if I would have total signs, or is that actually the same for all?
You wouldn't have to. No, this operator doesn't exist, no.
Okay. So just for plus and minus, I guess.
The arithmetic operators, yeah. Okay, this is the same logic in JavaScript, this time using nested ternaries, which looks a little bit messier if you ask me. I mean, it is still okay, right? I indented it correctly, but yeah, I like the switch better because it's flat and we can just read top down, don't have to indent it this way. Okay, let's now talk a little bit about static types. Axel kind of gave it away in his introduction already. We are statically typed and we don't have to explicitly add type annotations to be statically typed. So every single line of reason code you've seen in this presentation so far has been 100% statically typed, although I haven't written a single type annotation yet. Everything is just, the types have been inferred by Reason and OCaml. So this is the state of static typing in JavaScript, if I can bash just a tiny bit. And this is what it's like in Reason. So, okay. I want to show you some cool static types that we can use in Reason. And Axel has already talked about variants before. So here is a variant that I defined myself called a day of week. You can imagine this to be an enum, but again, much more powerful than enums in other languages. We're going to see why later. So I've just listed all the possible 7 cases for a day of week, right? We just have 7 weekdays. And notice that the type name day of week starts with a lowercase letter, and all of the variants, all of the constructors, they start with an uppercase letter. And that is not just a convention, that is how you have to name them. So your types have to be named lowercase and your constructors have to have an uppercase name. Okay, today is Thursday, so we can just write let today equals Thursday. I don't have to further qualify that. So I don't have to say day of week dot Thursday, for example. I can just write Thursday. And again, OCaml and ReasonML, they will infer that today is of type day of week, because Thursday belongs to day of week, right? I don't have to add a type annotation. I could write let today colon day of week equals. I could do that, but usually I don't do that. So.
But the first day is in the second type. What does it do then?
Well, it still works. But if I had another enum with, I don't know, weekend day, for example, which only defines Saturday and Sunday, if that was defined after my day of week, that would be the inferred type for today. And if you want to disambiguate that, you can still add a type annotation.
Yeah, usually what you do is you put it in different modules, you avoid this kind of case.
Yeah, so you want to avoid name clashing. I'm actually not talking about modules in my talk, but you can avoid these name clashes by properly scoping things in modules. Or adding explicit type annotations.
Do Monday to Sunday have to be previously declared? Or does declaring day of week also declare the individual members?
That is the entire declaration. So I haven't hidden anything.
Like it looks similar to TypeScript's union types, but
yes.
But there I wouldn't be able to just.
This is the definition. So there's no hidden type Monday equals type Tuesday equals. Okay. This is like writing in TypeScript const enum day of week, Monday, comma Tuesday, comma Wednesday, and so on. Okay. Yeah, this is the entire definition. So keep that definition in mind. We just have type day of week, all the 7 weekdays. We're going to need them. So this is what we can do with them. I have a function called abbreviate day, which just takes the day, switches over it, so it does pattern matching on the day, and returns the first 2 letters. Quite readable, isn't it? I think it looks really, really nice. Another function, I called it is weekend day, just determines if we have a Saturday or Sunday. In that case, we return true. Otherwise, we just return false. So you can see here, I'm matching one of these 5 cases, and if one of them matches, I return false. Otherwise, we return true. I could have written an underscore instead of Saturday and Sunday, because the only 2 cases that would remain would be Saturday and Sunday, but I just like to be very explicit here. And if we add an 8th day, we have to state later what we mean, if it's a weekend day or not. So if we add reason day, I don't know, is that a weekend day or not? So, yeah.
So would the compiler enforce our switch to be exhaustive?
Aha, very good question. I did not pay him. The question was, would the compiler enforce that we have an exhaustive switch here, so that we covered every single possible case? The compiler would compile it even if we didn't, but you would get a warning. You will see in just a second.
And you can configure it. Even if you want to get an error, you can get an error.
Yeah, so you can basically turn compiler warnings into compiler errors so that your program doesn't even compile. I'm going to show the error message first, but I recommend that you actually do that, so that you opt into the strictest compiler mode, where if you get a warning, you treat it as an error. I know some people don't see it that way. I know many C# developers, for example, who just say, well, if it was important, it wouldn't be a warning, it would be an error, right? So we can just ignore it. But in my experience, if the compiler gives you a warning, it's a good idea to not have this warning. So treat it as errors. All right. Can anybody spot what's wrong with this code?
Reason day is missing?
Reason day is missing? Well, that is correct, although reason day was not one of the constructors of day of week. But you get points anyway.
Thursday is
Thursday is missing. Okay, I just removed one of the cases. This is what my code looks like in Visual Studio Code. It just gets squiggly lines. And if I try to compile my code, this is what the output looks like. And I just want to give a huge thanks and shout out to the Reason team who have just made the error messages so awesome. The error messages and the warnings. So the compiler tells me in friendly, helpful human language, you forgot to handle a possible value here, for example, Thursday, which is an amazing error message, in my opinion. So you really know what you did wrong here, right? The switch was not exhaustive, which means that we didn't handle every single value that we could possibly get. Looking at the code again, true, we didn't handle Thursday, put it back in, everything's fine again. And this also works if I now go to my day of week type definition and if I add reason day, because now I suddenly have 8 constructors, didn't handle all of them, so we would get the warning. Had I used the underscore before, so had I used underscore instead of Saturday, Sunday, I wouldn't have gotten a warning, because then we would have been exhausted, right? Underscore would be like a default in a JavaScript switch, handling everything that we didn't handle so far. Okay, one more type definition. I called it a time of day, morning, afternoon, evening, night. Quite simple, right? Nothing new. And now I want to talk about how we can group values together. And one way we can do that is using tuples. Actually, Googled before if people say tuples or tuples. According to Twitter, 38% say tuples and the rest says tuples, so I'm going to stick with tuples. So here I'm creating a tuple on the fly. I'm just grouping Thursday evening as our meetup date and Saturday night as party time. This would be syntactically valid JavaScript, by the way. So if we had Thursday evening, Saturday, and night somewhere defined, that would run just fine. Does anybody know what the value of meetup date would be if this was JavaScript code? Well, of course, Benedict and Axel know. You've written JavaScript books, you write JavaScript compilers. Anybody else? Yes?
I think it would be evening, right?
It would be evening, right. So what's the official name? Sequence expression, comma operator? Comma operator, yeah. So in JavaScript, we would evaluate all of these expressions. So we would evaluate Thursday first, we would then evaluate evening, and the result of the comma operator would be the last expression, so the result of the last expression. Quite tricky because it looks like JavaScript has tuples, or tuples, but it doesn't. So in JavaScript, we could, I'm not saying we should do this, but we could simulate tuples by just using arrays of a fixed length. Just saying, well, we use an array of length 2, and we call that a tuple. That is what TypeScript does, for example. Or can do, if you tell it to. The problem is, JavaScript doesn't have static type checking by default. And if I put in values here that don't exist, like, for example, Thursday late, which wasn't part of our time of day type, JavaScript, of course, doesn't catch that, because why should it? It's a valid string, it's a valid array, it's fine. And that just can't happen in Reason, because all of this is statically type checked. So if I typed late instead of evening, that wouldn't compile. Okay, almost at the end. We've seen tuples, which are position-based. So all the components in the tuple are identified by their position, right? So in this tuple, we have the day of week, comma, and then the time of the day. And we can't swap them, then the type would be different. If we define a record type that kind of looks like a JavaScript object, we can give names to these components. So they're no longer position-based, they're name-based. Okay. So this is a simple record with 2 fields. It has day and time, and I've also specified the type. Again, the day and time type has to be lowercase, because that is how we write type names. again, it pretty much looks like a JavaScript object. And that would be a valid reason value. So we have a let binding here called party time, and we assign the day and time fields. Quite straightforward, I would say, right? This is what it would look like in JavaScript, but again, we don't have static type checking here. Yes?
Do I have to define a record type, or can I just use this let expression and have it implicitly typed for me?
You have to define the type first. You have to have a type definition.
Okay,
Yeah.
so if I write this without a type definition, then something bad will happen.
So if you just typed in this into RTOP, for example, you would get an error, yes, because you don't have type definition for the record. You wouldn't have a type definition for Saturday and for night.
Okay.
So this assumes that this code is running as well.
Okay.
And that code assumes that we have day of week and time of day.
Okay, great.
Yeah. So there's no such thing as, we just make up arbitrary shapes. We need named types.
With objects maybe, right?
JavaScript objects. So
No, if you use OCaml objects, if you use ReasonML objects, I think then you get ad hoc types and
so if you do curly brace dot,
yeah, then I think you don't need to declare.
but then you would have to quote the property names and
Yeah.
And
Then you-
does
you
it work?
can-
I don't know
yeah.
actually. Does it work?
If you do 2 dots, then you can do that.
Okay.
So then it goes.
No, I mean if the dots are only for the type
For the type definition, yeah.
But if
But
you
I mean-
just want to run ad hoc values, you can also like just quote the day and time. Then it's interpreted as an object, and then you can like just arbitrarily.
Yeah.
But it's JavaScript space. This is pure reason code now.
And it's different. So these JavaScript objects, they're different from records. So if you look at the code that, for example, BuckleScript generates, records, they're compiled to arrays and numbers. So the names of the fields even disappear. Just look at the compiled output. This is pretty interesting. Okay, that was Reason. That was JavaScript. And this is, again, Reason how the syntax for accessing the fields of the record. We can just say partytime.day, partytime.time, nothing surprising. And I was really pleased to see that we can also do destructuring, just like we can in JavaScript. And that is really cool, because again, that is familiar syntax for people writing ECMAScript 2015 or any sort of modern JavaScript flavor. Familiar syntax. This is actually syntactically valid JavaScript. All of it. Yeah, it's quite cool. Okay, final topic. I want to talk a little bit about nullability, because many programming languages have null, and everybody always jokes that null is the $1 billion mistake, while JavaScript has null and undefined, so we have the $2 billion mistakes. If you want to add them, if you want to multiply them, it gets even more expensive. Why is that a problem? So let's assume we want to parse, I call them indexes here, I don't even know if that's the correct word. If we want to parse numbers into our weekday representation, okay? I told you that 0 stands for Sunday, so we can just list all the 7 cases, but what happens if we pass anything else than 0, 1, 2, 3, 4, 5, or 6? What do we do in JavaScript? What would you do if you had to write this function in JavaScript? Throw, maybe? Range error, or just error something? What else could we do?
Return null.
That would be my next suggestion. We could return null. I mean, if he names his chapter nullability, okay. Yeah, so I would do one of the two things in JavaScript, right? I would either throw, or I would return null, maybe not undefined, but yeah, you could also return undefined. And Reason we can be a little more explicit about this, and I love that part, because it really helps us avoid null errors. So instead of returning a plain weekday, we now return a wrapper. And that wrapper is called option. We're going to see the definition in just a second. So the idea is we either return some value, or we don't return anything at all. So this none means we don't have a value. It's like a missing value. It's like null, but more. So it's hard to explain. So an option can only have one of two cases, right? Has a value, it doesn't have a value. You have to pick either of the two. And you do this by wrapping the value in the sum constructor if you do have a value, and if you don't have a value, you just return none. And this is a really cool solution because it allows us to not throw in this case. So notice the underscore, right? I'm handling everything else by just returning none. So this is a total function. It returns an output for every valid input without throwing or having undefined values. And the good thing is, people calling this function, they don't have to remember that they have to check if they have a value or not. We force them to check it. We're going to see what that looks like. So here's the type definition for the option type really quickly. It's a variant with two cases, either none or some. And this prime A is a generic type parameter. So we can parameterize the option type. So you can have optional strings, optional floats, optional ints, optional whatevers, but we only have this type definition once. So we don't have like an optional int, optional string as separate types. We have a generic option. Okay, again, this is our function. How would people use it? Well, I've written another function called isValidDayIndex, which just tries to parse the day and then pattern matches on the result. Because sum and none, I can pattern match on these two, right? I can just say, if I have sum whatever, true, it is a valid day index. And if I get a none, it's not a valid day index. Simple as that. And there's no simple way, no way around that. So I cannot say, I call parse day and then I say dot value and force the value out of the option. That just doesn't work. I have to pattern match. And pattern matching does two things at the same time. It checks if the pattern has the structure, and then it binds the values to the names we provide, but only if it does have the structure. So it's like a safe check, and it just works beautifully, if I can say that. Okay. One more example. We had this abbreviate day function before, which just returned the abbreviations Monday, Tuesday, and so on. So if I wanted to show a certain day, identified by index, I could just parse it. If that works out, I print out the abbreviation. And if it doesn't work out, I have to write out some fallback value, right? And the beautiful thing here is I just can't forget to do that. Because parse day does not give me a day. It gives me an option day. And I have to look into the option to see if I have a value or not. So if you do something similar like that in JavaScript, you always have to remember, okay, I have to check this for null because it could potentially be null. Or if you go with the range error that we had before, you have to remember that parse day can throw. And then either add try catch or let the error bubble up. But this I can't forget, and this is really beautiful. Okay, this is the output for the numbers 4, 6, and 7. I hope you believe me. This is where you should go if you want to read more about ReasonML. I talked a little bit too long, but yeah, thanks for listening anyway.